Solve for x in the equation 3 to the power of 2x minus 18 equals 3 to the power of x minus 1. So that looks quite tricky, especially because we've been told to express any answers in exact form. So that means do not use a calculator. We've got to use the analytical methods. So let's write it down. 3 to the power of 2x minus 18 equals 3 to the power of x plus 1. Now, what we're going to do, we're hoping this can lead to a quadratic equation and we can get a dummy variable involved. Now, this particular arrangement that I'm going to do for the 3 to the x plus 1, you'll see this all over topics in the IB, this particular rewriting or just writing in a different form. So 3 to the power of x minus 1, we're going to write as 3 to the power of x times 3 to the power of 1. It's just sort of reversing the first index law. This 3 to the power of 2x, well, you could think of that as 3 to the power x squared. If you think about, well, if I just use the third kind of index law on that, it would get to the same place anyway. The 18, I'm just going to leave as an 18, minus 18 equals, and I've just said I'm going to say this is 3 to the x times 3 to the 1, because it's a lot easier probably to think about it this way around. If I say, well, what's 3 to the x times 3 to the power 1, you could say, well, it's 3 to the power of x plus 1. So now, if I can just move the stuff around and make it equal 0 on this side, I have 3 to the x squared minus, so I'm going to subtract this term, so 3 times 3 to the x minus 18 equals 0. So now I've got something that I think I can make into a quadratic equation. Well, it already kind of is, but I can make it look a lot nicer if I use a dummy variable. Personally, I always use a u. So I'm going to say let u equal 3 to the x. So this must be u squared minus 3u minus 18 equals 0. Now we've got a really friendly quadratic in u. So now we look to factorize. Hopefully it'll factorize. So hopefully we're going to have a u and a u, and we're going to make 18. So 6 and 3, different signs, minus 6 plus 3, minus 6, and that looks good. So that means 3 to the x plus 3 to the x minus 6 equals 0. Right, so now we can use the null factor law, and we can say, well, either 3 to the x plus 3 equals 0, or 3 to the x minus 6 equals 0. So if 3 to the x plus 3 equals 0, that would mean that 3 to the x would equal minus 3. And if you think about raising 3 to a power to get minus 3, well, it's not possible. You think of the graph of 3 to the x, it has an asymptote at y equals 0. It does this. So it doesn't ever go to minus 3. So there are no solutions for this particular value. So what that means is we disregard this particular solution of 3 to the x equals 3, minus 3. So now we work on the other one, which is 3 to the x minus 6 equals 0. So 3 to the x minus 6 equals 0. That would mean that 3 to the x equals 6, which is definitely possible. We've been asked to solve this exactly, so we're going to have to now take logs of both sides. So ln. Remember, if you're not sure, use a natural log. In fact, you should just use a natural log. ln of 3 to the x equals ln 6. Third law says you can move the x to the front. X ln 3 equals ln 6, which would mean that x equals ln 6 over ln 3. Do not be tempted to try and simplify that. It doesn't simplify. I know it looks really inviting, like you can cancel some ln's, or you can use a law, or you can divide 6 by 3, something like that. You can't. It is finished. That is the answer. We are done.